Rahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Today's session is just a bonus lecture on working in Visual Studio Code and Python virtual environments. In this course of tools and techniques for data science, we have been working in Jupyter notebooks for learning different data science and machine learning related topics and their proof of concepts. Before moving on to deploying a machine learning model, which we will do in our next session, inshallah, I thought it appropriate to create a bonus lecture on writing Python programs inside VS Code and creating a virtual environment for our Python project. Well, VS Code is really a great tool to manage your entire data science and machine learning lifecycle. And you can download and install Visual Studio Code by visiting the official website. It is a free source code editor by Microsoft. You can click this drop down to download VS Code for your respective OS, be it a Mac, Linux, or Microsoft Windows. And since we have been using Anaconda Navigator so far, let me open that up as well. And once you install VS Code, this VS Code will appear up in the home tab of Anaconda Navigator. Over here, you can also see Spider as well as this PyCharm, which are full-fledged IDEs for professional development in Python. Well, interested students can check out Jupyter Lab as well, which is quite similar to Jupyter Notebook, but having a bit heavy memory footprint. But at the same time, this Jupyter Lab offers more functionalities than this Jupyter Notebook. Let me click this launch button of VS Code and come up to the welcome screen. Its default theme is actually dark, which is good as it saves battery life of your laptop as well as put less stress on your eyes. But for the presentation sake, I prefer a light theme. If you want to change the theme, you can click this gear icon over here, click themes, color themes, come up over here, change the theme of your choice. But for the time being, let me keep it light. Great. My dear students, if you see on the left, you can see this activity bar shown in black, having few icons at the top and two at the bottom. This Explorer icon at the very top opens or toggles Explorer panel, which you can use to explore your file system of your computer and you can create new files and folders as well. Let me just click this open folder, come up to my file system, downloads directory, and this is the project 1 directory, which is empty right now. This is the directory in which I want to create my project files. Let me open it. Let me just close this terminal right now for the time being. You see inside the Explorer now I have project 1 as my current working directory. After this, we have this search icon on the search panel to search files and directories from the folders you are in. VS Code gives you the facility to connect to Git repository as well. You have the facility to debug your programs. You have extensions as well. My dear students, VS Code has support for a bundle of languages like Python, Julia, R, C, Java, PHP, HTML, CSS, JavaScript, and so on. And you can program in VS Code in any of these languages using extensions, which are actually a way to fine-tune this code editor. You can also think of these extensions like apps on your phone. There are extensions for almost everything, from programming languages and debuggers to formatters and themes. Let me just come up over here and just press enter with this empty. It has two lists. these are the installed extensions on my system right now inside VS Code, and these are the recommended ones. Let me search for the built-in. Okay, so let me click built-in. So we have features, themes, and programming language for the built-in extensions. As far as the features are concerned, let me check out GitHub. Okay, so GitHub for Visual Studio Code. This extension offers features like pushing, cloning, and forking GitHub repositories. And similarly, under themes, you have different themes, and under programming languages, you have support for basics of different programming languages. Let me just click this C++ basics, which provides syntax highlighting, bracket matching, and folding in C files. Let me search extensions by typing at category. And it shows you different extensions by categories now. And extensions related to cloud, data science, debuggers, machine learning, programming languages, and so on. Let me click programming languages. Now it shows you a list of extensions related to programming languages. Let me click this Python extension for Visual Studio Code. It of course provides a rich support for Python language versions 3.7 and onwards, and it will automatically install these two Pylase and Jupyter extensions as well. Well, this is also a good README. Under the quick start, it says just install Python interpreter, this extension, and start coding in Python. Well, if you go further down, it tells you how to set up your environment. If you also install Jupyter extension for VS Code, you can run Jupyter notebook files with the .ipynb extensions inside VS Code. And it has support for different language kernels as well. So these are some of the useful commands which can be opened by pressing Command plus Shift plus P on Mac OS and Control plus Shift plus P on Windows or Linux. So this will open up the command palette, and once you install an extension, its appropriate commands comes up or appears up in that command palette. So one of the command that you will find very useful after installing this extension is select interpreter, which is used to switch between Python interpreters, its versions, and different environments. Okay, so okay, over here we have some feature details and supported locales as well. Well, I have already installed this. Let me come up over here and show you some other. Let's talk about CMake. So this is CMake. I have not installed it, so you can see that I can click this button and install this CMake. That is an extension that provides support for CMake in VS Code. And great job done. My dear students, if you want to check out the installed extensions that I have, you can type at installed. Yes. So these are the installed extensions. I just want to show you so that you should be able to install these. I personally suggest that you should install this Python IntelliSense by Microsoft and this Jupyter extension by Microsoft, at least for today's session. I think this will do the job. Now it is time to run a Hello World Python script. Let me come up to this Explorer now, and by clicking these icons over here, I can create new files and directories. Let me just create a new file with the name of, let's say, hello.py. So this is the hello.py file. And do notice that as I pressed enter, the file opens up in a new tab in the editor pane. So let me just write a hello world program. Let me write a program that calls the factorial method of the math module to calculate the factorial of a number. For that, let me do a import math as m. And after that, let me create a number. Let me say num is equal to 5, and let me calculate the factorial now by using the factorial method of the math library. Let me pass it num, and now I have the factorial. I just need to print it. Let's say print factorial of let's say num is fact, and let me put a dot over here and say format, and let me give the variable names to be placed inside these placeholders, num and factorial. Good. Now we have written the script or program in Python, and now the next step is to run this script. The simplest way is to click this icon over here at the top right. Well, once I click this, this will open up a terminal over here and execute this script in a particular environment. If it doesn't run like this, you can press Ctrl Shift P to open up the panel, select the interpreter, and you can select one of the interpreters over here. Right now, the interpreter which is running is 3.9.13 base Conda. Let me escape. You can look at the right bottom and this taskbar over here. It shows the interpreter in which it has run. This can also be observed from this base parenthesis that appears before this prompt. And this is the same environment in which we have been working up till now in our Jupyter notebooks. Okay. My dear friends, another way to execute this program is from the terminal. Just write down Python and the name of the file, and it will execute. Once again, factorial of 5 is 120, of course. And remember, this hello.py has to be in the current working directory, and it is of course there because my present working directory is project 1, and inside project 1 I do have hello.py. One more thing, my dear friends, if you want to run this program line by line, you can just press Shift Enter. Let me clear this terminal. Right now my cursor is over here. If I press Shift Enter, you see the Python interpreter has run in interactive mode, and it has executed this first line. If I come up over here and press Shift Enter, it has executed the second line. Now it has executed the third line, and now it has executed the fourth line. So you can execute your Python script line by line. And to exit this interpreter, press Ctrl D. Great. If you want to execute a portion of your code, let's suppose that you just want to execute this much of your code, you can highlight this code and press Shift Enter. This is not working because of this shell, I think. Let me create a new terminal, and in that it will work, of course, I think. Let me execute just these 3 lines, highlight them, Shift Enter, and you see these 3 lines have been executed. So far, so good. Okay, so let me close this by pressing Ctrl D, clear the screen, close this interpreter again. Fine. My dear friends, so far in this course, we have been executing our Python code snippets inside Jupyter notebooks. If you want to work with Jupyter notebook files having .ipynb extensions, you need to install the extension pack for Jupyter. And we have seen them over here inside the extension link. You have this Jupyter notebook support, this file for Microsoft. Please do install it if you want to use Jupyter inside VS Code. Okay, so let me come up over here, close this, and let me press Ctrl Shift P to open the command palette, and let me say create new Jupyter notebook. So this command is there because I have installed the appropriate extension. Let me press enter. So it has created a new notebook for me. This has created a new Jupyter notebook with .ipynb extension. Let me save it by pressing Ctrl plus S, and let me name it, let's say, Hello Jupyter. I think this is a reasonable name, and save it inside the project directory, Hello Jupyter. Fine. Now, before we write code in these cells and execute them, we need to select the kernel. And the kernel is already selected. If it is not, you can just click this over here and select the appropriate kernel from this command palette. Now, this is a code cell. If you want to change it to a markdown cell, just click this, come up over here, and we have markdown. Let me say learning is fun, shift enter. So it has executed. Let me write down some code over here, a Python code. So change it to Python. Let me say print welcome to learning VS Code. Shift enter. Great. My dear students, I hope this makes sense and it's very simple and clear to you all. You can always open existing notebook files inside VS Code. I strongly recommend that you should open the notebook files that you have worked so far in this course and play with them. And let me move ahead. Okay. My dear students, after having a fair idea of running a Python script as well as a Jupyter notebook in VS Code, now let's talk about creating, activating, deactivating, and deleting Python virtual environments. Let me move to Anaconda Navigator first, and let me click this environments link and come up over here. You see the base environment having all these installed packages. And this is the environment in which we have executed our hello.py file, and this is the environment in which we have been working so far in this entire course. And before I tell you how to create a new virtual environment, let me answer the what and the why question first. That is, what is a virtual environment and why do we need it? My dear students, instead of installing all these packages system-wide, we create a virtual environment for every project and install only those packages that are required for that project. And one of the main advantage of building your project in a virtual environment is to prevent version conflicts. Let's suppose that you have created a project A that is working perfectly fine with a specific version of, say, library X. Later, due to the requirement of another project B, you upgraded that library X to a newer version. And there is a possibility that due to this upgrade of library X, your project A stops working. And the solution to this problem is you create virtual environment for your project and install packages inside that virtual environment. And of course, there are other more powerful alternatives like Docker and Kubernetes, which are containerization techniques. But in today's session, we will restrict ourselves to isolating our project using a Python virtual environment. So let me, you can do this over here as well by clicking this button at the bottom to create a virtual environment, but let's create it inside VS Code or from the command shell. Let me just open our terminal from here. So this is our terminal. I just want to create a new local environment. Right now I am in the base virtual environment, which was created using Conda. Let me first deactivate it by saying Conda deactivate. So it is deactivated. You can note the prompt is different now. You don't have the base parenthesis before the prompt. Let me just check out the present working directory. I'm inside project 1 and this is my project directory for which I want to create a virtual environment. So let me just press Command Shift P, and I need to just select the Python interpreter. I just need to select it, and this time let me select this Python version 3.11.1. So let me click this. Okay, so now you can check out that if I come up over here, you can check out that this is the Python version. This is 3.11.1. Now, using this Python interpreter, I want to create a new virtual environment. So, to do that, you just need to give the command python -mvenv. So, since I am on the terminal, I will use Python 3. So this is the command, and after this I need to give the name of the virtual environment, and let me say the name is demo venv, that is demo virtual environment. My dear students, please do note that over here inside the Explorer window, inside the project one, soon we will have a new directory over here with the name of this demo venv, and you see the file is there. And a pop-up is also there. VS Code is recommending that if you want to change your environment to this new environment, you can click this yes, but I am not doing that. I want to do it manually for better understanding. Okay, so let me show you what all is there inside this directory, demo venv. It has three subdirectories: bin, include, and lib, and a file pyvenv.cfg, a configuration file. My dear students, if you are working in Windows operating system, you might see scripts directory instead of this bin directory. Anyways, inside this bin directory, we have different activation scripts for different shells which we need to execute to activate this virtual environment. On Mac, if I want to do that, I just need to say source, and I need to give the path of that activate script inside demo env, inside bin, and inside bin we have activate. And let me just press enter. And you see, after I have pressed enter, my demo environment is changed to demo venv. My dear students, on Windows, this activate script will be inside the scripts directory instead of bin directory, and you simply have to execute that file. Okay, so let me now say activate demo venv. So it says permission denied. Okay, so let me just select it from there. Command Shift P. I'll open the command palette, select the interpreter, and you see we have this demo venv over here. It might be the case that it turns up a bit late at times, but it will of course turn up. So let me select this. Now you see we have this 3.11.1 demo venv virtual environment. So this is the virtual environment which we have just created, in which we will run this file now. And to run this file in this virtual environment, I just press this play button and it gets executed. Factorial of 5 is 120. Great job done. Let me clear the terminal. And let's change the this Python program let me just add another line in it, and let me import the NumPy library. Import NumPy as np. And we all know that NumPy library is not built into Python. Let me just execute this script now, and you see it has raised an error, and that error says module not found error, no module named NumPy. My dear students, although we have NumPy in our environment, but that environment is the base environment. That is not this demo venv. This demo venv is the environment we have just created, and we have not installed a single package in it. And naturally, math module comes bundled with the standard Python, but NumPy doesn't. And for that, we need to install NumPy. And to install NumPy from pip, let me just upgrade pip first. Let me say python -m, and let me say pip install -upgrade pip. So we are done. And let me come out of this base. Let me close this. Let me close this. Let me open up a new terminal. Come up over here. So it's still this base. Okay, it's fine. I think I'm in demo venv. It will not cause any problem. Let me install numpy now. Pip install numpy. So it will take a bit of time to install numpy. Now once numpy is installed in this demo venv, if I press the play button now, it will not cause any error, rather it should execute successfully. Yes, it says factorial of 5 is 120, and of course it has not raised any error for this particular import. In a similar fashion, my dear friends, you can keep installing different libraries and packages as the requirement arises in your project. And let me take this opportunity to tell you about another important file that is known as requirements.txt, which is a simple file, a simple text file that saves a list of all the modules and libraries along with their versions required by your project. To create it, you can use the pip freeze command, do the output redirection to requirements.txt file. So once I press enter, you will see a new file will be created in this project directory, that is requirements.txt. So this is the file, and voila, this says numpy equals 1.24.2. So my dear friends, this requirements.txt file contains a list of all the packages and libraries along with their version which this project requires actually. Now a $100 question is where to use this file. My dear friends, suppose you want to deploy this project on a server and want to install all these libraries over there. You can always use pip to install all these libraries one by one. And another very good option is you use this command, pip install -r followed by the name of this file. And once you press enter, it will install all the files that are there in this requirements.txt file. Great job done. Let me just deactivate now. So we have deactivated. Let me come out of conda as well, this base as well. For that I need to do conda deactivate. I'm out. And to delete this virtual environment, I simply have to delete this directory, demo venv. So let me do that. Let me say rm-rf demo venv. Let me press enter. So it is deleted. So virtual environment is no more there. Well, I think that is enough as far as virtual environments are concerned. Let me now spend 2 to 3 minutes on debugging a basic Python program in VS Code. And for this, let me create a new file. Fine. Let me create a new file and let me name it, let's suppose, factorial.py. So this is a new file, factorial.py. I just want to write down a function over here which is passed a number and it returns the factorial of that number. So let me write that program, a user defined function with the name of, let's say, func, and it is passed a number. This is a function, and let me declare a variable fact equals 1 for I in range. Let me run the loop up till num number of times, and let me say fact is equal to fact into I. I think the logic is quite simple, makes sense, and let me just return fact. So this is the user defined function that is passed a number, it runs a loop and returns the factorial after computing it. And let me call this function, let me say number is equal to, let's say, 5, and let me say rv is equal to this function, and let me pass it this number. And now let me print the result by saying print factorial of this is this, and let me use format, and let me pass The variables to be placed in these placeholders, that is number and RV. Great. I think it's enough. Now let me open up, run this program in a terminal. Let me run it in the base environment, and let me say conda activate, or rather let me use this terminal, Control Shift P, and select interpreter, and let me use this base. Okay, fine. I think we have this base. Now I can press this to execute. So it has executed. Factorial of 5 is 0. Great. And you can always do conda base. Nope, conda. Okay, sorry for the typo. CUNDA. Fine. And now I can execute it like this as well. And the name is factorial. Now the problem is, my dear students, factorial of 5 is not 0. I think it is 120. This program has a logical error as it is running correctly but giving me a wrong answer, a 0 instead of 120. The mistake I have made might be visible to you as this is a very small script and a single file, but we want to learn debugging from this program by correcting this program. And my dear students, you all know that debugging is a science, or some people say it is the art of finding and eliminating bugs in your computer programs. And a debugger is actually a program running another program. So let me put a breakpoint at this place over here. Fine. So I have just clicked it, and I have placed a breakpoint over here. And you all know that a breakpoint is the line of code where you want to stop the execution of your program, and you can set as many breakpoints as you feel like. And now let me just click this run and debug icon in the activity bar, and this will toggle this run and debug panel. My dear students, you can customize your debugging by creating a launch.json file. But for the time being, let me just click this run and debug button, which will open the command palette with a lot of related commands. And since I just want to debug the currently active Python file, so let me just click this. And you notice that the program has started its execution and is halted by the debugger at the breakpoint, which is highlighted in yellow color, and the taskbar also appears in a different color, orange right now. My dear students, when you are in debug mode, you will notice that there are several features that are available. Excuse me. On the left hand side, we have the debug sidebar, and at the very top, you can see a drop down showing different launch configurations over here. And this gear icon over here, this one, will open up your launch.json file. Let me just click it and do this. And this is the launch.json file. You can change the debugging configurations. Please explore it at your own time. And let me, for the time being, just close this file and come up to over here. Well, in the sidebar, you also have your variables, both local and global. You can see you have watch, where you can set a watch on a variable. And then you have this call stack for different function stack frames that are pushed on the stack, and the breakpoints, which display a list of all your breakpoints, and it also show options for adding function breakpoints, deactivating or toggling the breakpoints, and removing all the breakpoints. Moreover, you can click this overflow icon at the top to customize your debug sidebar as well. Anyway, at the bottom of the screen you have the debug console as well over here, and at the top over here you can see the debug toolbar in the center. Moving from left to right, you have this continue or pause your program icon, step over, step into, step out, restart your program, and stop debugging. Well, my dear friends, our program is still halted at this break point. If you have your mouse in the code editor, if you hover it over this number, you can see the value. You can see the value over here. You can see the value. If you hover your mouse on different variables, it shows you a tooltip with the value of that variable. Okay, now we can click this step into. Let me click this step into. Let me click this. You see I is equal to 0, num is equal to 5, fact is equal to 1. So when fact is equal to fact into I, we will get a 0 in this fact. Let me again do a step into, and I keep doing step into. The I keeps increasing, but factorial remains 0. So I think we have got the problem. And the reason is quite clear. That is, the loop is running from 0 to 4. This range function, once I pass it num, and num is 5, the loop will run from 0 to 4, while it should run from 1 to 5. So let me just close this and correct this program. Let me run the loop from 1 to num plus 1, which will make it run from 1 to 5. I think this will do the job. Let me simply run this program now. Python, and the name of the program is factorial.py, and I have not saved it, so you can see this dot. Let me save it by pressing Command S. So it is saved now. Let me execute it again, and you see, great, the factorial of 5 is 120. Great job done. My dear friends, one thing that I am skipping is the source code. I'm skipping the use of Git in Visual Studio Code. My personal preference is that I prefer working on a command line, and I have covered Git and GitHub for data scientists in our video section 1.3. Let me show you that over here. 1.3, I have covered in detail all the nitty-gritties about Git and GitHub. You can watch that video if you have not watched that. You all must be knowing that Git is actually a program for managing the source code, while GitHub holds a copy of that code in an online repository. Please go through this video to learn about Git and GitHub. Let me fall back to VS Code. Okay, and if I just click this source code icon in this activity bar, you see this. Using this, you can initialize a repository, you can add and commit files, you can create branches and merge them, and you can also connect your project with GitHub and do all the push, pull, and clone. My dear friends, if you are interested, maybe I will create a video on this as well in some later part of this course. But for the time being, I think that is all for today's session. And I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.